Hello everyone, welcome back to Innovative Minds. So today we are going to be looking at the recent AMC10A problem 24. So the first thing we see is of course a fair six-sided die, so we can immediately think of this as a combinatorics problem. But without further ado, let's get into the problem, see how we can solve it, and see what kind of strategies you could have used on test day in order to solve this problem. So a bee is moving in a three-dimensional space. So clearly we see 3D coordinates, so we need to keep that in mind. A fair six-sided die with labels A+, A-, B+, B-, C+, and C- is rolled. So we have a die with six faces. Suppose the bee occupies the point A, B, C, and if the die shows A+, then the bee moves to the point A + 1, B, C. And if the die shows A-, then the bee moves to the point A - 1, B, C. So basically, whatever point it shows, like A+, for example, it'll move in the A positive direction. Otherwise, it'll move in the negative direction, and that goes for B and C as well. So suppose the bee starts at the point 0, 0, 0, and the die is rolled 4 times. What is the probability that the bee traverses 4 distinct edges of some unit cube? So, of course, it's going to be a unit cube since we only ever travel one unit in either direction. So, let's actually start by setting up our probability. So, probability equals desired outcomes over total outcomes. So, of course, what is our total outcomes? We spin the die 4 times, and there's 6 phases on the die, so just 6 to the 4th. So now let's try to find our desired outcomes. And to do this, we will just basically simulate every one of the 4 rolls and see how many combinations we can get that will be desired and that will form the unit cube. So let's start off with the bee starting at 0, 0, 0. So the bee can actually go in any direction here because they are just forming the cube to start. So we have 6 combinations. So now let's say the bee goes in this direction, and now the bee is here. So in order to form the cube, it can't go straight again, because that won't be unit, that'll be too long. And it can't go back, because then it won't travel 4 distinct edges. So it has four desired combinations for the next one. So now that the bee has sort of traveled in this L shape, we know that it actually basically maps out a face for us. And now that we have a face, we know that there are only 2 possible cubes that we can draw. So we can either go in this direction, go in this direction, or go in this direction, where these 2 arrows are these 2 arrows are in the Z direction. So there will be 3 combinations for this. But if you notice, now we actually will have to split this 3 into 2 different cases. Since if we go in either Z direction, we draw a distinct shape that can only be part of one unit cube. So for example, if we have like this L shape, right? And then we head in this direction, like that, we have basically drawn our cube, and the only way we can go is like this or like this. So 2 combinations. However, if we go in this direction, now it still only maps out one face. So we can still go in 2 different cubes. Go in this direction, go this direction, or we can go down and complete the square. So we will actually have to split this up into cases. So we have 6 times 4, right? And then case 1 will be, we just continue on the same face. So this will be one of the choices and multiplied by 3 possible outcomes. And then case 2 will be, there's 2 combinations for this, and there's 2 possible ways we can continue. So 2 times 2 is 4, 1 times 3 is 3, so this is just 7, right? So our options are 6 times 4 times 7 over 6 to the 4th. So we can cancel out the 2 6s, right? So this will be 4 times 7 over 6 to the 3. And then if we cancel out the 4 and then cancel out the 4 here, we get 7 over 54. So that is our final answer, which would make the correct answer choice B.